Hello dear friends, welcome to this video. In this video, as you can see, we are going to work on the basic concept of series and some standard example. What is a series? The main reason to study sequences is we want to get some information about the series. But the way we study, we first study sequence and then we talk about series. But the main reason was to just study series, we started working on sequences. So now what is a series? Given any sequence, let me just write, given any sequence an, if I add all the elements of the sequence, let me tell this to be summation of an where n running from 0 to infinity. This is said to be my series of that sequence a. Okay, so a series of real number will look like this. Summation n running from 0 to infinity an for an inside real numbers, right? Now, when do you say a series is convergent, right? Everybody of us has heard this term convergent series. What is the meaning of it? That means when you add all the infinitely many numbers, your answer is converging towards some number, and that number is over here denoted by L, small l. Whatever is that number is less than infinity. So students should be very much clear about the concept. Whenever we say a series is convergent, we don't say the sum is going to be that. We say that the sum is going to be near to that L as n tends towards infinity. This is the concept behind it. Convergent series means what? The sequence of partial sum of that series converge towards it. What is sequence of partial sum? If you just keep adding the term one by one, so it could be like, if in this case, how could I understand this? It is nothing but I'll write a1, then I'll write a1 plus a2, then I'll write a1 plus a2 plus a3. I'll keep finding out. Every time I'll just increase one term. So if you observe this addition would be a sequence, and that is called as a sequence of partial sum. Now the sequence of partial sum converging towards L, that means my series is converging towards L. The sum of all the infinitely many numbers is going close to L. And what is that L? L is some finite number. In that case, we say that the series is converging. Okay. Is this concept clear? Yes. Let's just go further on the basic concepts of series. After understanding what is meaning of a series and what is the meaning of a convergent series, definitely there are some questions that might arise, and that is nothing but called as an absolutely convergent. Everyone of us has heard this term. Being a TY students or any mathematician, we have heard this term. Absolutely convergent. The name itself gives definition. Convergent means the sequence of partial sum will converge towards some finite number. Absolutely means whenever you take sequence of partial term, you are supposed to take the absolute of all the term. That means in this case, I would like this mod of a1, mod of a1, mod of a2, mod of a1, a2, a3. That means what I'm taking, I'm taking just the absolute values of each term. And if this thing converges towards L, then I will say that it is absolutely convergent. In a simple word, the series is same, but each term has got positive now. If it is negative, it has got positive. It is positive, it is considered as it is. Right? That means if I take summation of mod of an and it is converging towards L, where L is some finite number, then we say that series is absolutely convergent. Right? So these are nothing but the two types of a main convergence based on which the question could be asked. Whenever we study anything in mathematics, the most interesting part is to study the relation between those things. The same thing goes over here. We should know the relation between convergence and absolutely convergence, which implies which and which does not imply the other one, right? So whenever a series is absolutely convergent, it is going to be convergent, and you can justify to yourself why this is so, right? You should justify. Take your time, just talk to yourself. Unless we don't talk about mathematics to our own self, we never understand. Just try to justify. Every absolutely convergent series is convergent. Okay. So this is the result that I am giving, a wonderful result. And I hope each one of you could justify why the statement is true and why it should be true. I'm not asking you for the proof, I'm just asking. Just try to see that it is so trivial. If something is absolutely convergent, then that series must be convergent. Why is it so? Just logical thinking, right? Whenever we just write some implicit statements, the next thing that comes in mathematics is nothing but the converse of that statement. That means if a series is convergent, will it be absolutely convergent? If it is so, then both the statements are equivalent because both are if and only. So let's see what is your thinking on it. If a series is convergent, will it be absolutely convergent? The answer of this question is no. And if I want to disprove some result, I need to give some counter example. That is a way to disprove, right? So I should give you some counter example. So I have a series minus 1 raised to n minus 1 upon n, where n is running from 1 to infinity. This is a series which converges towards ln2. That means this series is converged. But if I consider the absolute part of that series, that is nothing but, if I take absolute part, it will look like this. This minus 1 raised to n minus 1 will become 1 because absolute value is going to be 1 divided by n. And the series is divergent. The proof of why it is divergent could be done by the students, or they must have already done, but this is something that students should remember. Right? So this is nothing but the some standard thing that students should know before going forward with series. That is, what is the meaning of a series, what is the meaning of a convergence, what is the meaning of absolute convergence, what is the relation, why the converse is not. To make it more clear to students, I want you guys to write one example of a convergent series which is not absolutely convergent. Just think of some example. You can Google it, but when you will Google it, you will just find out some example. You will read about it and you will understand more. So if you are watching this video, I just request you just search one more series which is convergent but not absolutely convergent. And if we get multiple example in the comment section, many other people can utilize it, right? Okay. Let's go further, but we hear something special happening. Right? A series was convergent but not absolutely convergent. This is a special situation. And this situation is called conditionally convergent. That means a series itself is convergent, but when you take an absolute value of each term, it is not convergent. So that kind of situation is called conditionally convergent. This terminology might be used in the examination, so students should know. Right? Just read it. We already done one example, the previous one, that minus 1 raised to n minus 1 upon n, which converges towards ln2, is conditionally convergent because it's self-convergent but not absolutely convergent, right? Okay, let's go for the next thing. There are some standard series that students should remember for any competitive exam. Because if you observe, real analysis is such a paper in which if they ask something which is very difficult or very complex, you cannot never answer. But most of the time in JAM examination, they will go for some standard things because all the students are from TY or they are appearing for the TY examination, right? So let's just note down some standard series which will be very helpful to you. The first is nothing but the power series, that is nothing but x raised to n. So my series x raised to n, where x is some real number and the power is my variable n running from 0 to infinity. This is convergent if and only if whatever x is over here is between minus 1 and 1. I just said between, not equal to them. Right? So suppose if I have this n running from 0 to infinity, 1 by 2 raised to n. So on the place of x, I have considered half. then in that case it is convergent and it will converge to 1 divided by 1 minus x. So in this case I can write this is converging to 1 divided by 1 minus half, and that is nothing but equal to 2. So we can say this series converges towards 2. Right? So similarly, you can get the answer for this in the chat box. Just let me know what would be the answer of this, where it will converge. It is very basic thing. Think about it, and if you can answer that, just try to answer me this as well. 1 by 20 raised to 2n. Just think about this also, right? So when you will solve this, you will understand it is very basic thing, and we just have to take one step ahead to get the complex part. So the first is nothing but the power series, that is nothing but summation x raised to n. That is convergent if and only if the mod value of that x is less than 1. And in that case, it will converge to what? 1 divided by 1 minus x. If a student remember their school time geometrical progression, I think it is the same, right? You can observe it. Now, suppose I have a similar series, but in that case, they have multiplied it with n plus 1. It is x raised to n, but it is multiplied with n plus 1. In that case, also it is convergent for x mod x less than 1, and the answer is nothing but 1 divided by, that means where it is converging, that limit is nothing but 1 divided by 1 minus x square. Right? So I just give a number so you can answer me in the check box. Question number 1. Question number 2 answer, you can let me know in the comment section. Question number 3 over here. The question number 3 that I am going to make is nothing but this. Right? So I just try to make it simple as I can. So it is 2 raised to 3n. I think it is easy. N is running from 0 to infinity. Right? Just let me know where it is converging in the comment section. Let's go further. As I said earlier that my series 1 by n, where n running from 1 to infinity, this is divergent. Even it is divergent if you take 0.5. The power of n, if it is p, then the answer is converging to some finite thing if your p is greater than 1. Otherwise, the series is divergent. That means the sum is going towards infinity. It is keep on increasing. Right? So whenever you take 1 by n to the power some number which is less than or equal to 1, between 0 and 1, then the answer is divergent. Whenever you take it greater than 2 or 1, greater than 1, the answer is going to be convergent. Right? So if somebody asks you what is this 1 by n square, what is the same as? I would say I know it is convergent. Where it is converging, I don't know. Right? So this is one of the question. If somebody asks me what is this cube, it is convergent. It is converging towards some point. I don't know that number, but yes, it is convergent. Because what I am just saying, I am just saying the p, the power of n. Right? If it is greater than 1, it is convergent. Right? So there are some other standard series. Let us just try to note them. So one of the famous and more interesting is nothing but telescopic series. What they do is they have some sequence with them, that is A1, A2, A3, dot dot dot. They have the series. By using the series, they create they have the sequence, and by using the sequence, they create one series, but in a special pattern. That means they do it like an minus an plus 1 as their first term, where n goes from 0 to infinity. So if I just try to evaluate this, I get it as A0 minus A1 plus A1 minus A2 plus A2 minus A3 plus A3 minus A4 and keep on going. I hope now the student can understand that my this and this get cancelled, this get cancelled, this get cancelled, this get cancelled. So what would be left? The final answer would be that A infinity, the last number would be left and the first number would be left, right? Nothing else would be there. So the answer, this is converging toward A0 minus A infinity. Now A0 is the first term, I know, but what is A infinity? A infinity is nothing but the last term in this. So the last term in this, if it is converging towards L, the last number is going to be L. So it is A0 minus L. When can I write this? I can write this if and only if the series or sequence. It is sequence, right? It is the sequence which converges towards it. So what is a telescopic series? A telescopic series is obtained by doing subtraction of two terms of a sequence. And the answer is going to be A naught minus A infinity. And if your A infinity is nothing but the limit of the sequence is defined, then the answer is nothing but A naught minus L, where L is that limit. Right? The value of the series is nothing but A naught minus L. As I said earlier that I don't know the value, I remember I have searched for this value, that 1 by n square is nothing but pi square by 6. But this is one of thing which might be used, but rare cases. I had that curiosity of knowing where it is going, so I just searched about it. So it is summation of n running from 1 to infinity, 1 by n square is nothing but pi square by 6. Right? So this is something that student can note it down. Might not be so much useful, but it is an interesting fact to remember, right? Let's see some other series as well. What I give is, I just give the list to you all. Just try to note them down. These are nothing but some standard series that student must remember for their examination. Okay. Just note them down. Each one of them could be used somewhere, somehow. Okay. So I will just suggest note them down, try to understand them. In the next video, we'll be going further with the convergent test and some previous year problems. Okay. For this video, thank you so much for joining me. I hope you like the video. If so, don't forget to like, share and subscribe to the channel. Bye bye.